Okay, guys, we're going to talk about a little bit about solutions. You have a PowerPoint over solutions. It's very informative that you need to look through the slides and get information on. At the end of that PowerPoint, you're going to see something about molarity. So if you're looking at my picture here, molarity basically describes how concentrated your solution is. So the abbreviation for molarity is an uppercase M. So whenever you get ready to do lab with powerful or weak acids, stronger weak bases, they always have a number and this big M. Like, for example, a 1 molar hydrochloric acid solution is not extremely strong. Okay, that word concentrated just means how strong is it. A 0.1 molar acid is diluted enough with water that it really wouldn't affect you at all if you got it on your skin. It's not great to have it on your skin. You'd still want to wash your hands, but it's not going to eat your hand off. All right, so if you look at my picture, you can see some acids you can get on your hands and they're not going to hurt. You would still wash them off. Bases as well. Some bases can be very weak. Get it on your hands, you're gonna live. You're gonna be fine. Or you're gonna have some acids that are extremely strong, more like 3 molar, 6 molar, 18 molar, that are eat your face off or burn a hole through your hand. Okay, so let's talk about an actual problem that involves molarity, because what we have to be able to do in chemistry is solve for concentration. We need to be able to know if we're mixing stuff together, how concentrated would that solution that we're making be. Okay. All right, so the formula for molarity is big M equals moles per liter. This would be moles of your solute. This term solute implies what are you dissolving? What am I putting in a liquid that I want to dissolve? Okay, and we need that unit to be in moles. Okay, the next thing is liters of your solution or liters of your solvent. Okay, it must be in liters. So if you're given a different unit in a problem, you must convert it over to liters, and I'm going to show you how to do that. So let's look at an example, okay? I just want to mention that the universal solvent in chemistry is typically water. If you want to dissolve anything in a solution, if you're trying to make a solution, you're going to be putting that in distilled water. So water is typically what we call the universal solvent. Most anything will dissolve in it, okay? Let's look at a problem. So if you need to pause the video, pause it and write down this question. When you get done, play it again. You have 125 grams of NaCl, which is table salt, in 500 milliliters of water. And what is the molarity? Well, here's the problem. If you're looking at that, this is not moles, it's grams. This is not in liters, it's in milliliters. So I promise on your end of course, this is what they're going to give you. They're not going to give you moles. They will give you grams and tell you what it is. They're not going to give you liters. They're going to give you milliliters to try to trip you up. But you have to convert that over to liters in order to plug in here. The only thing you can plug in here is moles and liters, right? So we're going to start by doing that. The first thing I'm going to do is change this over to moles. So to do that, I have to divide by the gram formula mass. Now, if you watch me set this problem up, I wrote what I was given. I drew my X, I drew my line. Whatever I have over here must go on the bottom here. Remember that universal rule about units and conversions. The unit you're given must go on the bottom. What you're trying to get to must go on the top. Here we're dealing with grams of sodium chloride. And where would we find a mass amount for sodium chloride? Remember, one box on the periodic table is a representation of a mole. So in order to convert to moles, we need the masses from the periodic table. So I have to come over here and add up the GFM, or molar mass, of NaCl. When I add that up, I get a total of 58.44 grams per mole of NaCl. So I'm going to plug my mass in here. And now I simply work that out by dividing. Anytime you're multiplying by 1 over a number, you're actually dividing. So when I work that out, I get 2.13. But I'm going to, you can use a whole number. You can give 1 or 2 decimals as long as you round correctly. I just stopped at 2. It's 2.1 moles of NaCl. So now I have my mole amount. Now I must take my milliliters and change to liters. Okay. You're going to have to memorize this. If you're not good with the stair step, just know from milliliters to liters is 3 steps. It's 3 steps back. Milliliters is a smaller unit than liters. So if this is smaller, that means that this number, when I change it, is going to get smaller. This number is going to get smaller. All right, so from milliliters, if I was working on the stair step, it's 1, 2, 3 steps back to the left. So 1, 2, 3. So 0.5 liters. So now I have my 2 units that I need for my formula. I have 2.1 moles and 0.5 liters. So I'm going to write my formula. And I'm going to plug and chug. My mole amount is 2.1. My liters is 0.5. And that should be close to 4, but I'm going to check the math. I get 4.2. My unit is a big uppercase M, which stands for molar. So this solution, this is the strength of it, 4.2 molar, okay, of a sodium chloride water solution. And that's how you calculate molarity.